Number 13, a horse pulls a covered wagon west across the plains of Kansas. I always like to draw pictures, so we're going to draw a wagon, please pardon my art, and our horse, there's my horse, don't judge my horse, is going to have a force of 2,500 newtons, or 2,500 newtons. It also says the horse is pulling the wagon moves along with a constant velocity. All right, constant velocity. If I'm moving at a constant velocity, then I know that my forces have to be balanced. The only way to have a constant velocity is to have no change in motion. The only way to have no change in motion is to be balanced. What is the magnitude of newtons of the force of friction acting against the force? So the only two forces acting on this box are the horse, which is over here, and he's pulling with 2,500 newtons, and friction. Friction is pulling the opposite direction. The only way to make this balanced is if this frictional force is equal to the horse's force. They have to be equal to each other, otherwise it is not balanced. So the magnitude of the force would be, and here are our boxes. Again, guys, a lot of you like to not get the decimal right. So if this is our decimal right here, then 2,500 is going to be where you're writing in your place values. The decimal, it needs to be at the end of that number. And number 14, when an object is acted on by an unbalanced force, the object will do what? Unbalanced force causes a change in motion. And what do we call a change in motion? It can be change in speed or direction. We call that acceleration. So F, continue in the same direction? No, same. It is not going to keep going the same direction. It is going to change. Continue at the same speed. It will not do something. It will not continue on the same thing. Accelerate? Yes, it will accelerate. We even wrote that word down. Oh, it might also come to a stop. However, it says that when an acted on by an unbalanced force, the object will, which is the better answer. It might stop, but it will always accelerate. So the better answer is going to be H. And yes, we know that this is very similar to a question we had before. We apologize for that.
Number 15, it takes 3 hours to drive a distance of 192 miles. So 3 hours is going to be my time, and 192 is going to be my distance. The value you would calculate with this information is V. Okay, so instantaneous speed. This word right here is the speed that you're at that particular time. The current speed that you're at. So for instance, let's say like if you're running around a track, or if you're in a car, you start out slow and then you speed up, and then you hit traffic, and so you have to slow down, or then you speed up again, and then you hit a red light, and so there's all kinds of different speeds. That is what we call our average speed. That is the total distance divided by the total time. So displacement is just how far you've gone in a distance. Velocity we know is both speed and direction. So the correct answer here, we've got a total distance and a total time, so that is going to be our average speed.
Okay, so on this particular question, it says, in the diagrams below, 2 forces are exerted on an object. The forces are represented by arrows. So first of all, it says that 2 forces are exerted on each of the objects. The length of the arrow indicates the magnitude. So this magnitude, this word means strength. So however long it is, the stronger it is. So in which of the diagrams will the motion of the object remain unchanged? So this basically right here, if it's unchanged, we're looking for balanced. So which ones are balanced? Okay, so this one and this one look like they're equal, so I like this one. This one does not have the arrows showing that it's going like this. So this is unbalanced. It's going in this direction over here, so that's wrong. This one here, it has some coming from a smaller one coming from the top, and so it's kind of going like this. Eventually, we'll kind of go in that direction. So that's wrong. This one is smaller.
than this one. So this one's going to be moving. The balanced one is going to be up.
Okay, when a satellite is in orbit around the Earth, the force of gravity on the satellite, well, when a satellite is in orbit around the Earth, clearly we know satellites orbit, if this is Earth right here, they're going around, so they are always going to be turning or changing direction. They might be going the same speed, but they will be changing direction. So the force of gravity on the satellite pulls the satellite out towards space. No, if it did that, then it would be going out towards space. We know it doesn't do that. Causes a change in direction of the motion. Well, what do you think makes the satellite continue to go around? It's that constant force of gravity pulling in that's making it change direction. Kind of like when you grab a string and you spin around, the string has a ball on the end of it. You pulling in on that string keeps that ball going in that circle. As soon as you let go, that ball is going to go flying out into space. It's so small it can be ignored. Obviously not. Gravity is not small. Earth's gravity is big. Causes the speed of the satellite to decrease. No, it's not decreasing. It's at a constant speed. It's just constantly changing direction. So just like you pulling on a rope, spinning it around, holding a ball, that ball is going to keep going around in circles as long as you hold on to that rope. That's what gravity does for those satellites. So the correct answer is B. Okay, number 18. A sailboat is traveling east using its motor for propulsion. So here we have our boat, and the boat is traveling east. Remember, it's never eats sour watermelons. When a strong wind begins blowing to the south. So the wind is going to be coming from the south. Right there, as a result, which of these forces will the boat travel in which direction? Well, if it's going east from the motor and south, it is going to go in a diagonal direction. It's going to go toward the south and toward the east. So our best answer is G. A boat sliding across the horizontal table. As it slides, it slows down. Slows down. So I am already starting to think acceleration and unbalanced forces. Which of the following statements best explains the situation? There is a balanced force on the book caused by gravity. Well, we know it's not balanced because it just said it slows down, so it cannot be balanced. There is no upward force acting on the book. Is the book falling? It is not, so there has to be an upward force matching that downward force of gravity. There is an unbalanced force on the book caused by friction. Okay, there is an unbalanced force caused by friction. Well, what would slow the book down as it slides across the table? Something has to be working against motion, and we know that friction always works against motion. And there are no unbalanced forces. No, there are clearly unbalanced forces because it is slowing down. So C is our best answer. Okay, number 20. Joe pushes a box with a force of 16 newtons to the left. So Joe is pushing to the left. So he has a force of 16 newtons pushing this way. That's to the left. Anne pushes the same box from the opposite side with a force of 10 newtons, and she's going to the right. This is going to be Anne. What will be the results? The box will move up. Well, no, there's no upward forces, so there's no way it's going to move up. The box will not move because 6 newtons is not enough to move it. Well, the net force is 6 newtons. 16 is bigger, so it is definitely going to move. It is going to change. It's going to accelerate because the net force is not equal to 0. The box will move to the left because the net force of 16. The left is the bigger force right here. So that looks like a good answer. The box will move to the right. Definitely not to the right because the right is the smaller force. So H is our answer. Okay, guys, and that is it. And just remember, it's a reminder, in order to receive credit back on your test grade, you must dump on every single question, no matter whether you got it correct or not, and you must write every single thing that we have written. If we wrote it on the paper, it needs to be on your paper to receive credit. This will be up on Google Classroom for a while, and this will be due on Friday. We will possibly have some class time on Wednesday, October 2nd, not guaranteed, but if you have class time, great. If not, you will have to do it on your own time, or you can come in after school and get it done with us. Good luck.